over time we see that each individual plate on our planet is changing size and shape. So this video we're going to talk about why they're changing size. So the entire surface of the Earth is constant. The Earth doesn't get bigger or smaller over time. So as we have plate tectonics occurring, if we have one plate that is getting larger in size, this means to compensate, another plate will inevitably have to get smaller in size. So we see that each individual plate can change its size and shape depending on the types of boundaries along its edges. If it's surrounded by divergent plate boundaries around spreading centers, where new lithosphere is being created, those plates are going to grow, like the African and Antarctic plates are growing today. It's because they're surrounded by divergent plate boundaries. On the other hand, if we're looking at a plate that's surrounded by convergent plate boundaries, where we have subduction zones destroying lithosphere, those plates are going to be getting smaller over time, like we see with the Pacific plate. Because it's surrounded by convergent boundaries, that oceanic plate is getting smaller over time. So what does this all mean? At the beginning of this chapter, we talked about Alfred Wegener and his hypothesis of continental drift. He came up with this idea that there used to be a supercontinent called Pangaea. Now that we have a better understanding of plate tectonics, we can actually figure out exactly how Pangaea broke up, and the continents and oceans ended up being in the locations where they are today. So just overall, if we start off at A, this is what Pangaea looked like 200 million years ago, right before it started breaking up into smaller continents. The first thing that we see when we look at B is the separation of North America and Africa. The Atlantic Ocean is beginning to develop between them as these continents are being rifted apart. When we get to C, we'll notice that Southeast Asia has now collided with the rest of Eurasia, while the Atlantic Ocean is continuing to diverge and get bigger. By the time we get to 50 million years ago, now most of our southern hemisphere has broken up into the continents, and India has made a pretty decent journey from near the South Pole to the equator. By the time we get to 20 million years ago, shown here in E, we'll see that Asia has continued to solidify into one continent. But we also see that we have a full Atlantic Ocean between the Americas and Africa, and that India has completely collided with Eurasia. And when we look at today, the most significant features that have developed is that divergent boundary going through Africa and splitting the continent of Africa away from the Middle East. So knowing all that we know about the past of plate tectonics, it can actually give us a better understanding of how these plates are going to move into our future. So if we look at the Earth in 50 million years, which is shown in the image on the left, we'll see that Africa is actually going to be getting closer to Eurasia, and that the Atlantic Ocean is going to continue getting wider and wider. But this is going to look vastly different than the Earth in 250 million years in the future, which is the image here on the right. You'll see that way into the future, eventually another supercontinent will form, where we have all 7 of our continents together as one again.